Miss Prince here with your science video for this week. This week we are talking about the engineering and design process. In your packet, you should each have a paper that looks like this, talking about flooding. On PBS.org, there's an interactive activity where you get to design a city and make sure that it's safe from flooding. Now, before we do that, we're going to watch this engineering design process video, and I'm going to put the links for both of these below this video on YouTube as well.
Determining the structure of a skyscraper is complex and technologically challenging. Engineers rely on a step-by-step design process to guide their work. So, where do they start? Identify the challenge.
Designing a building is sort of like any sort of problem solving. You first need to identify what the problem is you have to solve.
The building is like the end of a process. It isn't the beginning, it isn't the start.
Once the design challenge is identified, engineers are ready to do research and brainstorm.
Brainstorming is a vital part of the process because as you design a building, you come up with new ideas.
In my experience, the first solution is never really the best one. In the process of brainstorming, I get different ideas from different people.
While researching, engineers weigh the benefits and costs of each design decision, both to the project itself and to society. These considerations are called design constraints.
I have this phrase that I use as a guideline for my work, and that is, a building must be safe. S-A-F-E. Primary, it must be safe. Safety is important. A stands for it must be aesthetic. It must look good, and it must suit the need for which it has been designed. F, it must function properly. By functioning, I mean it must have sufficient size and shape and access and so on, so that people don't feel somehow uncomfortable. And E means there is an economic side to it, that I must make sure that at the end of the day, the price that it's supposed to cost, that's what it costs.
The next step is to design a solution. Engineers use the information from their research and brainstorming sessions to come up with a variety of possibilities to solve the original challenge.
All right, I'm going to pause here to again show you this paper that you have in your packet. This is your brainstorming paper. This asks you questions like what causes flooding in cities near rivers or oceans? Where in cities is flooding the biggest problem? What materials or spaces in cities do not absorb water? That means where you're going to see puddles, you're going to see flooding, you're going to see roads that are impassable because the water has covered them. Where will you build your city? On an island, in a river, or on a peninsula? What goals are you trying to meet? List at least 2 materials you will use to keep your city from flooding. Where will you put your fidget homes? These fidgets are our fake people that we're trying to keep safe from flooding, and why? And then you're ready for step 3. Build and test your design in the game that I'm going to pull up after this video.
They then make drawings and plans outlining their ideas. But how do they know that their design will work? They test their ideas.
For engineering, testing is very important.
We need to make sure that what we're doing is going to stand up against the forces that act on it.
Engineers build a prototype or model and then test the prototype to make sure it will stand up against load or forces that will act on the structure, like gravity and wind. What comes after testing? Evaluate.
To evaluate it means that you have to take a look at your solution and see whether it solved the problem. We may give it to some other engineer who will check what you're doing, just as a teacher would check a homework problem.
The engineering team presents their solution, but if the design doesn't solve the challenge or satisfy the constraints, it's back to the drawing board. More research and brainstorming, new designs and retesting. Only when they've come up with the best possible solution is the design process complete, and they're ready to build it.
Before you build a structure, you need to identify what tools you have.
Where are all my materials going to come from? Who's going to build it? How many people? And what skills do they need to build it?
And at each step in the process of building a skyscraper, engineers evaluate their work and the work of the construction team. Like engineers David Pravat and Susan Knack, you can use the step-by-step design process on projects of your own. Identify the challenge. Brainstorm. Design a solution. Test ideas. Evaluate. Build it. The next time you look at a skyscraper, a bridge, your own school even, think about all that goes into building it. Think big.
Awesome. We just looked at the steps of the design process for engineers, and now we're ready to test out a plan. Now, I'm not going to write out a detailed plan on this paper like I want you to do because you're going to view it as backwards, but I'm going to show you how you test your plan to see if your fidget city will flood or not on the PBS interactive game right here. This is Don't Flood the Fidgets.
Don't flood the fidgets.
You'll click play.
The fidgets need your help designing a city that's safe from flooding. A flood happens when there's lots of rain, wind, or anything that moves water from its usual place. There are many things that can cause floods. If there's too much rain, the banks of a river can be flooded. When there's a hurricane, strong winds can push water to the shore, causing an ocean to flood. An underwater earthquake can cause a huge wave that can flood the land.
Click OK.
Here's how to play. You'll be building a city where the fidgets can live safely. This is how many fidgets are in your city, and how many you need. These are your fidget dollars. Use this money to buy materials to build your city. Tap on a material's name to learn how it helps you build your city and prevents flooding. Tap a material in the toolbox to select it. Draw or stamp the material onto the board to build your city. You can earn power-ups for this game in the virtual world, Cart Kingdom. Tap Undo to erase the last thing you added. Tap Delete to erase things from the board. Tap the fidget to flood your city. You'll lose any homes that flood, but you'll be able to rebuild them. You can flood your city 3 times. Let's get started. Choose a city to build.
All right, so you get to choose if you want to build a city on an island, on a river, or on a peninsula. I'm going to choose a river because Chattanooga is beside a river.
Build a safe, dry city for 550 fidgets to win. You can spend up to 100,000 Fidget dollars to build your city.
All right, so we have 100,000 Fidget dollars and we have 550 fidgets that need to live in this city. Now, if you go over here to the build icon, it shows you in a house, 5 fidgets can live. In a house with stilts, 5 fidgets can live. In an apartment, 20 fidgets can live. And in a green roof apartment, 20 fidgets can live. I'm going to use the green roof apartments because that green roof will help soak up extra rainwater.
Apartment with a green roof where 20 fidgets live.
Let's see, I'm going to put one here. 20, 40, 60, 80, 100, 120, 140, 160, 180. We've already got 180 fidgets living in this city. Let's see. I can put some more back here. 200, 220, 240, 260, 280, 300, 320, 340, 360, 380. We've got 380 fidgets living up here in the safer section. It's a higher level of land, so it's less likely to flood. Now let's go back to our build and see what else we need to put in.
Levee.
So a levee protects land near the river from flooding. Do you think we need a levee maybe if we want to build some houses in this bottom area? Let's see. Just put a levee here.
Green building materials like swales, rain gardens, and pervious pavement will help your city stay dry. Try adding some.
Okay, it won't let me add a levee right now. Let's try a swale.
Swale.
Just trying to line the whole river. Let's see. Okay. Now make sure you're watching your money. Every time I add a swale, $150 goes away. So we've spent that on adding a swale. Okay, now I've lined the whole river, just one right there, with swales. We've got 380 out of our 550 fidgets living here. We still need a little less than 200 fidgets. 100 and, let's see, doing math in my head, 550 minus 380, that's 55, minus 38, 48 is 10, and count up. $170 fidgets still need homes. Alright, I'm gonna add some green roof apartments right down here. Here's one, Here's one. $480, $500, $520, $540. We just need 10 more fidgets. So let's add a couple houses.
House where 5 fidgets live.
These houses are going to need to be extra protected. So there's 5. And there's another house right here.
Wow, you've built homes for all your fidgets. You can keep building, or tap the flood button to see if your fidgets' homes will be safe.
All right, we have all our fidgets here, but I'm not quite sure that they're going to be able to survive a flood yet. We've only got swalls and these green roof apartments to protect them from flooding right now. So let's go and add some rain gardens around our houses and our apartments that are lower to the ground. And what else?
Road made from pervious pavement.
So pervious pavement allows the rainwater to soak through it. I'm going to make a road out of pervious pavement through the city so that hopefully the rainwater won't make it to any of the homes. Okay. Now we still need stormwater inlet.
Stormwater inlet.
This is helpful near roads. So I'm going to put a couple along our road to keep the rain from collecting. Let's see.
Wetland.
I don't know if we need a wetland right now.
Tree.
Let's add a couple trees to help soak up some of this water. All right, what do you think? Do you think we have a pretty good barrier? I don't know what's going to happen, but we've come up with a plan. We implemented this plan. Now it's time to test it so then we can evaluate and see what happened with our design. I'm going to go up here and click flood.
A big tropical storm is coming, with rain and waves that can cause flooding. Let's see how well you protected your city. Uh-oh, your city flooded.
Oh
Here are your
no!
results.
Okay, So we lost 7 homes. We still have 440 fidgets living in our city, but we need 550 fidgets living here. So now would be the time to evaluate and say, how well did our design meet our goals? We almost made it. 440 fidgets survived that flood, but not all of them survived. So we're going to have to go back and plan again. I'm not going to go through that whole process because that would make this video entirely too long. But your goal is to get to a city that survives the flood completely. All 550 fidgets live through the flood. Then after that, you would evaluate your redesign. A redesign is when you go back and design again to try and fix some of the problems. So it says in our city, the swales helped and the rain garden helped. Next time, it wants us to try some wetlands and some canals and put more swales and rain gardens around the homes. All right. Good luck, friends. If you need any help with this at all, please reach out to me, comment below, reach out to your teacher. We are here to try and make learning from home as fun and interactive as possible during this time. Bye, friends.